Today we will discuss the portion of physical chemistry. In the previous class, we have already discussed about organic chemistry, where we have the second book, which was of 33 marks. Today, as I said, I'm going to discuss about three chapters, which of course include solutions, that is of 7 marks, electrochemistry with the maximum weightage of 9 marks, and of course the chemical kinetics, which is again of 7 marks. We will be discussing about all these chapters and one by one how exactly from the physical chemistry the questions are basically being asked. So let's start. Here, of course, if you see, the total is 7 plus 7 14 and plus 3 23 marks. This is of 23 marks. So physical chemistry is of 23 marks. So what are the things which are important in the physical chemistry? Of course, all the important formulas and numericals. Then in the chemical kinetics, basically the questions are asked from the graphical portion. Then of course the reasoning based questions, assertion reasoning based question, and MCQs. Now let us start. Let's go to the next slide. This is the solution where from last 3 years continuously one question is basically being asked: is the difference between a ideal and a non-ideal solution? Of course, the positive and negative derivation is also being asked, but the most important, as I said, is nothing but it is the difference between an ideal and a non-ideal solution. So this is the graph of an ideal solution, and we are supposed to write down this only, that when the AB interaction is equal to or almost equivalent to AA and BB interaction, then it is nothing but it is actually called as an ideal solution, where delta H of mixing and delta V of mixing is equal to 0, and as such forming an ideal solution is next to impossible, but this is only being considered. On the other hand, if I'm talking about non-ideal solutions, we have one with a positive derivation, another with a negative derivation, where in the positive derivation delta H of mixing is greater than 0, that means positive endothermic reaction. Delta V of mixing is greater than 0, that means 10 plus 10 will be equal to 20 ml. Sorry, not 20 ml, it will be greater than that, maybe 20.2 ml, I'll say. And the example include maybe water with methanol, or you can say cyclohexane with ethanol, or acetone with ethanol, and so on. On the other hand, when we're talking about negative derivation, we have the graph in the opposite way, and the interaction between A and B is actually greater than AA and BB interaction. What I mean to say is interaction is weaker in the beginning and it become what strong after interaction, or after, I'll say, will be more strong. So a tendency to go into the solution will decrease, and that's why this will show negative derivation from the Raoult's law. Best example is in between acetone and chloroform, because when we are talking about acetone, neither acetone neither chloroform has a tendency to form hydrogen bond, but when you try to mix them, you will find that they are capable of forming an hydrogen bonding between both of them. So a very good example of negative derivation. Next, which we are supposed to take up, is all the colligative properties. I hope you remember what our colligative properties are. Those which depend upon the number of solute particles but are independent of the nature of the solute particle. So there are 4 colligative properties that we are supposed to take up. Number 1 is of course called as the relative lowering of vapor pressure. The formula is this, because the numerical can be asked from this formula, and of course it is applicable in dilute conditions only. The second one is called elevation in boiling point, where the formula will be equal to delta TB is equal to kbm, or I can write here delta TB is equal to I kbm if I am considering Van 't Hoff factor I into weight divided by molar mass into 1000 divided by volume V, and of course the molar mass, sorry, this will be the mass of the solution, and of course this is the molality only into kb. So this is one formula on the basis of which numericals can be asked. And then of course this is a very simple graph between vapor pressure and temperature. So these are the two colligative properties that we have already done. The next is, of course, the next colligative property is depression in freezing point, where we are supposed to write down that delta TF is equal to IKFM. I can write delta TF is equal to KFM when we are supposed to take up a non-electrolyte, which include your sugar, urea, etc. But if we are considering an electrolyte, that will be equal to IKFM. For example, the questions you might have seen when it is asked that a KCl shows almost twice the elevation in boiling point or twice the depression in freezing point in comparison to that of glucose or maybe urea or maybe of sucrose, because the Van 't Hoff factor for them is 2. So both reasoning and numericals can be asked from this, and the most important here is osmotic pressure. When I'm talking about osmotic pressure, it basically include, number one, the most important is that when exactly we are supposed to call any solution as an isotonic solution. Of course, isotonic means which has similar osmotic pressure. They are called isotonic solutions. Now, the formula is pi is equal to CRT, where concentration is number of moles divided by volume RT. And of course, this number of moles is equal to weight divided by molar mass into RT divided by volume V. And then of course, if I am being asked to find out capital M, so I'll just shift this here and pi will come over here. This will be the formula that we'll be getting. Molecular mass will be equal to weight divided by pi RT divided by volume V. So one is this. Another important thing here is a very important reasoning question is that why out of all the colligative property, osmotic pressure is preferred for calculating the molecular mass of a substance. Number one, it is calculated at room temperature. Number two, even in dilute condition, it gives you more perfect values. Number three, it is molarity dependent rather than other three colligative properties are molality dependent. So this is another very important question that we have already discussed. The next part that I'm going to take up right now is, of course, as I said, Van 't Hoff factor, the most important. Number one, if you pick up any examination paper, they are asking in direct definition that what is basically Van 't Hoff factor is. So it is basically the ratio of the experimental value of the colligative property to that of the calculated value of the colligative property. Or I can write here the modified formulas I have already discussed with you, that I am going to put pi is equal to, I mean, suppose if I am writing pi is equal to CRT, just put I, now it become your, for electrolyte, or P naught minus P divided by P naught will be equal to I xi of the solute. Delta TB is equal to I kbm or delta TF is equal to I kfm. These are the formulas. And of course, as I said, Van 't Hoff factor is equal to the ratio of the observed value of the colligative property to that of the calculated value of the colligative property, or calculated molecular mass divided by observed molecular mass, because we know that colligative properties are inversely proportional to what? Molecular mass. So on the basis of this, I can calculate and these are the formula I minus 1 divided by n minus 1, or I minus 1 divided by 1 minus n, right, or 1 by m, whatever. So these are the formulas that are important from the colligative properties. Next, the numericals. The numericals can be asked, calculate the mass of ascorbic acid. Very simple questions are basically being asked from this. As in, like, an anti-freezing solution is prepared by dissolving this much gram of ethylene glycol, molar mass, this. Calculate the, so there is no difficult question as such which is basically being asked from this part. Simple question पूछे जाते हैं यहाँ से, बिल्कुल सीधे सीधे questions. Then another question is on the basis of Van't-Hoff factor, because one of my favorite, in fact पूरा चैप्टर Van't-Hoff factor के ऊपर है, तो Van't-Hoff factor से न्यूमेरिकल्स करना बहुत इंपॉर्टेंट है, बहुत जरूरी है. Then what I was talking about is Nernst equation. We have already done in detail about Nernst equation, especially where the questions are basically being asked from the Nernst equation. So I'm not going to take up in detail about the questions from Nernst equation. Now the next is numericals from the kinetics, where of course from zero order and first order the questions can be asked in the form of numericals, right? Next, then these are the graphical question. Graphical means strong electrolyte and weak electrolyte graph, which is very very important, where basically being asked that which is a strong electrolyte, which is a weak electrolyte, and how will you distinguish between strong and weak electrolyte over here. Then the most important nowadays questions asked is from predicting the order of the reaction. As you can see from here, the first is R naught and time का ग्राफ, तो जीरो ऑर्डर, ये फर्स्ट ऑर्डर का है. अगर आप ये देखोगे, दिस इज अगेन फर्स्ट ऑर्डर ग्राफ एंड सो ऑन. Then the questions basically like reasoning based questions. Why do doctors advise gargle with the saline water in case of a sour throat? Because it is a hypertonic solution. Why is the molecularity applicable only for elementary reaction and order is applicable for both? We know that because order, molecularity is basically the number of atom molecules or ions that are taking place or maybe participating in the slowest step or the rate determining. That's it. Next, measurement of the osmotic pressure method is preferred, as I have just now discussed, for determining the molecular mass of the macromolecule protein, etc., etc. We have already discussed. Then the questions like aquatic life are more comfortable in cold water than in hot water because the amount of carbon dioxide is more. Then elevation in the boiling point of KCl is nearly twice of that of 1 molar sugar solution. Of course, the Van't-Hoff factor calculated at room temperature. These are the answers of above that we have discussed, questions so far that we have discussed. Then assertion reasoning questions can be asked in the form of this. Elevation in boiling point is a colligative property. Then this is the assertion. Then what is the reasoning? Elevation in boiling point is directly proportional to molality. So C means what? Assertion is correct, reasoning is incorrect. Then similarly, 0.1 molar of KCl has a greater osmotic pressure than 0.1 molar solution of glucose at the same temperature. So these questions can be asked in the form of assertion and reasoning. And then multiple choice questions. These all questions which I am right now showing you are given in your notes. And especially these all are nothing but these are the board questions that are already being discussed n number of times while we have already discussed whether it is electrochemistry, whether it is solutions. For example, the amount of electricity which is required to convert zinc to zinc sulfate, of course 2 farad. And then zinc is coated over the iron to prevent iron coating of iron because E naught value is more important, right? So that means because zinc की E naught value जो होती है वो ज़्यादा नेगेटिव होती है in comparison to the iron. आयरन की -0.44 वैल्यू होती है और जिंक की -0.76 होती है, तो 0.76 वाले को आप प्रेफर करोगे. देन ये ग्राफ आपने पढ़ा हुआ है, मोलर कंडक्टेंस इक्वल टू मोलर कंडक्टेंस एट इनफाइनाइट डायल्यूशन ए स्क्वायर रूट सी. तो ये क्या है बेसिकली? दैट मीन्स कंसंट्रेशन इज अप्रोचिंग जीरो. अब एक रिएक्शन के अंदर ये हो रहा है कि कॉन्सेंट्रेशन को x को अगर हमने 4 टाइम्स, मतलब रेट जो है 4 टाइम्स हो जाता है अगर हम कंसंट्रेशन को डबल कर रहे हैं, तो सीधा सा यानी जो आपका 1/2 हो रहा है। द यूनिट ऑफ द रेट कॉन्स्टेंट डिपेंड अपॉन, यूनिट जो होता है वो ऑर्डर ऑफ द रिएक्शन के ऊपर डिपेंड करता है। तो वी हैव ऑलरेडी डिस्कस दीज क्वेश्चंस, whether it is multiple choice questions, whether it is your assertion reasoning based questions. So I've just given few ideas, right? Reasoning based question, then predicting the nature, graphical questions, and I have just not taken up, अगर आप देखोगे मैंने ये वाले आपके नर्म्स इक्वेशन के क्वेश्चन मैंने ज़्यादा डिस्कशन नहीं किया आपके साथ, आपको बता दिया बिकॉज नर्म्स इक्वेशन आपने बहुत अच्छे से की हुई है। ये इक्वेशन थी हमने की थी, उसके बाद हमने यहाँ गए, फिर हमने केमिकल काइनेटिक्स के 2 फॉर्मूलेस पढ़े, ठीक है। वंस आई विल शेयर द रिकॉर्डिंग, आपको यहाँ पता चली जाएगा, ठीक है। दीज आर द फॉर्मूला।